I'm a extension program specialist for water resources, and mainly I concentrate on landscape water conservation through design, plant selection, and efficient irrigation. I'm also a licensed irrigator, and I'm also a rainwater harvesting professional. So a great deal of the time when I give talks, I'm talking about rainwater harvesting off of homes or businesses in order to use that water for irrigation. Today we'd like to talk about it for greenhouse capture. And a lot of situations that I see from people I work with in the industry is they have no water, no reliable water supply. They're thinking about using well water, and when they find out that that well water, the aquifer levels have dropped, and it's not a reliable resource all of a sudden. And then also the supplier's too expensive, to get potable water to everywhere the greenhouse operation is. And then water quality becomes an issue, particularly with groundwater, if you have a well. And so quite a few times what I have gotten calls about is what I'm growing in my greenhouse is not doing well, what can be the problem. And of course then when we test the groundwater, it's too salty. The total dissolved solids is too high, the sodium's too high, the calcium's too high, and in some cases the nitrates are too high. So we've got to understand, if we're going to use well water, there might be a way to find out what kind of water is available under the ground where your greenhouse operation is. And so if we look at all the resources, the municipal water, which may be too expensive, may not be, the well water, the groundwater, the rural water provider will usually combine rainwater and surface water. Sometimes the municipal water is a combination of rainwater and surface water. Sometimes it's just one or the other, groundwater or surface water. And then we can look at rainwater. We can look at recycled water. We can look at gray water, and we can look at air conditioner condensate. I hope that you're going to consider rainwater collection, because rainwater is fairly clean in our area, depending on where you are, of course. The more air pollution we have, of course, the more acidic the rainwater is. But it still might be better than what you're going to be pulling out of the ground. As far as recycled water, this is water that has gone through the wastewater treatment plant, has been cleaned, and it is available for irrigation purposes. Not always good for a greenhouse because there's a lot of salts and metals in that. Gray water, I don't think that in a greenhouse operation you'd have enough available. And then air conditioner condensate, of course, that's pure water. And it's something that should be considered if you have a very big, large office building near you where you could collect that off. But water quality, we have to consider it for irrigation, because if there's a lot of calcium, of course, our irrigation methods might get clogged up due to that. Of course, we want to encourage the best plant growth that we can, and so the pH and alkalinity of the water makes a great deal of difference. Availability of the plant nutrients, again, pH, alkalinity, all of this has a lot to do with it. Damage to plants, because of the salt, because of too much sodium, too much calcium, too much nitrates. And then, of course, our potting material, our soil that we're using. We need to make sure that that doesn't get hydrophobic, and of course we have to consider if this is a long crop or a very short crop. And then we also have to consider, for water quality, the corrosiveness of that water. If it's a very high pH or a very, very low pH for that matter, we can get a lot of corrosion in our equipment. And then runoff from our greenhouse, not just from the roof. If we're going to collect that, wow, that's great. But you can see my picture here. This is my 3,000 square foot greenhouse, and I'm collecting the water off the greenhouse into rain barrels. There's 10 on one side and just one right here by the pump. But I'm also collecting the water that is being used in the greenhouse into this lagoon that I can pump out into my garden. What I want you to understand is that the Texas Water Development Board has a GIS website that you can go to, and this is the URL to get to that website. And if water tests are available to that well, you can actually see that. So this is an example, just a screenshot of the GIS system, and you can see these red numbers right here represent all the wells in this area, and I can click on one of these wells, and of course it will bring up the information about that well. Everyone should do that before they consider digging a well, because I've had one too many greenhouse operation and grower operations dig a well only to be bringing up salty water. So when we consider well water versus salty water, this is the type of thing we have to look at. The pH, the alkalinity, the total dissolved salts, the soluble salts, the hardness, the calcium, the magnesium, the sulfate, the chloride, the boron, and the fluoride. And then we look at rainwater and we can see that it's, it's a little on the acid side. We look at desirable greenhouse water, and of course we want it a little bit on the acidic side. Of course, rainwater has no alkalinity, very, very few dissolved salts. That's usually going to be from the air pollution or from the debris that has landed on the roof. Hardness, 17, of course, the desirable that's fine. Calcium, that's fine. Magnesium. And so you can see your rainwater is pretty doggone clean. Of course, it's only as clean as you filter it coming off your roof. And of course, if sediments get through, we need to talk about filtering it going out into your irrigation method. pH, of course, is something that we're all very, very concerned with. I actually use these pH sticks that I stick in and constantly testing both my city water and my rainwater, particularly before I start mixing up any pesticides or any fertilizer to see if I need to adjust that pH in order to have that pesticide or that fertilizer work the most efficiency. With a low pH, we may have excess iron and manganese, the calcium and magnesium deficiencies. With a high pH, we have other, sometimes minor nutrient deficiencies, but we need to know that. We need to know what this pH is to make decisions about buffering that pH. Total dissolved salts, soluble salts, this is very important. I've used this electroconductivity meter for, gosh, I think the one I've had is 20 years old. It's still very, very good. And of course, I can put a water sample in there and I can check that water, the electrical conductivity through that water, indicating about how much salts is. Not exact by any means, but it's a very, very affordable way for me to do it myself instead of sending my water sample off. Of course, this is what we're worried about, the sodium absorption ratio. We want that, less than 2, and this is particularly important for long crops, I grow orchids. I have had orchids in my greenhouse, the same orchids, for 30 years, and so, I'm going to keep these for a long, long time, so that becomes very important. Sodium, we want to be under 50 parts per million, and calcium, we want somewhere in between, 40 and 100 parts per million. Very important that we understand this and be able to decide, by using a chart similar to this, do we have excellent water, good water, permissible water, or very, very unsuitable water. Now, this is from Colorado State University, but also if you buy that meter for yourself to test your water, the chart will be in there with that. Now, greenhouse water, we all use different greenhouse water methods. It could be overhead. We might use it for cooling, for humidity, for fertilization, of course, for pesticide application. So our method of irrigation has a great deal to do with how those salts are going to build up in the soil. Do we have time to flush those salts out? And so you all know this from your use of fertilizer and the salt accumulating in the soil, particularly for our longer crops. And so the purity, I don't want to say purity, the quality of the water has a great deal to do with how we're going to do this. Many of us have put in different methods of, filtering our water, and there are all kinds of methods that we can choose to filter water to take those extra salts out, and I'll go over those in a minute. As far as for cooling, whether we're using a evaporative cooler on small greenhouses, a pad and fan system on our very, very large greenhouses, again, that quality of that water has a lot to do with the corrosiveness and how long those cool cell pads are going to last. For evaporative coolers, how long that metal is going to last, how long it's going to take to corrode, and of course the aspen pads in there, how often they need changing. So here I am in my greenhouse, in the back of my greenhouse. I'm filtering the water as it goes through the cool cell pads, but you can see the cool cell pads over here are very, very, very stopped up, and they need cleaning out, and there is a possibility that we can do a lot of cleaning of those, or we might think of replacing those. There's some newer cool cell pads out now that have a little bit of waxiness to them that are by the cool cell pad makers say it's going to last much longer and be much easier to clean. You can see that I have a clean out. I have it at both ends of my cool cell pad water, and so I can actually take this plug out of here and I can run a great deal of water through there to make sure that the tubing where the water is coming out is not also being clogged up by the calcium in our water, because that happens also. And instead of getting a good flow through that pipe dropping through your cool cell pads, you're going to get trickles, and that's an indication those holes are starting to get stopped. Sometimes I even lift that pipe up out of the housing and ream it out with a screwdriver or a nail to knock all that calcium out. Okay, the other way I use, this is underneath my benches in my greenhouse. I have a lot of gravel under there in order to hold a lot of water. And of course, when I do that, I've got these misters under there run by a hemostat. And some people want to use these fog systems, and of course you need really clean water for a fog system, so that doesn't get clogged up. This happens to be at the Fort Worth Botanic Garden Conservatory. So there's a lot of different ways that we're going to use water. Fertilizing is the other one. Most of us have some form of an injection system where we can inject fertilizer, and for that matter, even pesticides if we need to. And so in order to do that, the pH has to be just right. We need to test it to make sure the pH is right when we're mixing up our fertilizer, and then after we've mixed up our fertilizer, we need to make sure that that pH is correct also. I think most of us already know that, but I know there's a lot of people attending this, and I just don't know what your knowledge, and skills are to begin with. So I might be covering stuff that's sort of, I already know this stuff. Pesticide application is the other one. If we get our pH a little bit too low or our pH a little bit too high, we might not have, the pesticides working exactly like we want to. Of course, most of us are adding a surfactant, depending on if we're using spray or fog or what other method of application we're going to use. So we've got to consider what that pH is, and also, again, what that salt content is on our water. So when we talk about water treatment, and this is a typical RO method that a lot of people will be using. An RO method, a reverse osmosis method, removes about 95 to 99% of the total dissolved solids. And it also creates a salty wastewater. And of course, that salty wastewater has to be put somewhere that it's not going to damage any of the plants. A lot of us put it in the lagoon and mix it with rainwater or mix it with runoff water from our greenhouse, and then try to reuse it after filtering it again. But it has to be taken care of so it doesn't do any damage. Salty water is very corrosive. A de-isonizer, this lady has de-isonizer canisters in her greenhouse. Of course, this again is very expensive method. Acid injection to neutralize the alkalinity, decrease the pH, and usually we use phosphoric acid to do this. This is an old, reliable, true, proven method that many people use. Ozone and UV heat and sand filtration. Sand filtration has been around for eons, but ozone might be something new to everyone. Of course, ozone is a type of sterilant. A lot of water treatment plants are using ozone, and UV is the same way. It is to take all the impurities out of it. Of course, you need a lot of filtration, mechanical and charcoal filtration before it goes through the ozone injector and before it goes through the UV light. Heat is another one, but a lot of times that's not an option for greenhouse use because there's not a fast enough way to cool that water down. So what is the advantage of rainwater then? In most cases, it's all about salts. I grow orchids, and if I use my rainwater, there's no calcium spots all over my plants. Orchids are a long-term crop. From pollination to first blooming plant, I hybridize Phalaenopsis. That's 6 years, and a lot of times I'll grow it up 7 years, 8 years, and even 9 years to make specimen plants to sell to orchid collectors instead of the mass merchandise market. So I sure don't want calcium spots all over those plants. No corrosion of the equipment is the other advantage of rainwater because of the lack of salt and the slightly lower pH. Slightly acidic. What does that mean? Well, it varies with air pollution. So in the northeast part of the United States where we have a lot of acid rainfall, that would not necessarily be an option because the rainwater may be too acidic unless it was better than the groundwater or the municipal water that you can get. But, of course, then it would have to be buffered to bring that pH up to what we want it to be. Good for our fertilizer mixers, a slightly lower pH, and then also very, very good for our plants. This is a greenhouse operation, and you can see they have many, many, many different cisterns. They have a pump house here with the pump in it, and also a pressure regulator and a fertilizer injector. All their equipment is in this well house. Whether you have a large operation or a small operation, public, private, commercial, you can collect the rainwater and use it for your irrigation. This happens to be in Florida. I took it out front of the greenhouses because this is an operation where they grow interior scape plants. Again, having nice clean plants without calciums all over the plants is very important to them to make these sales. These are what are called Pioneer tanks. The metal actually comes flat when it's shipped to you, and there's a liner that goes on the inside. You can cover these with a flat metal roof, or you can cover them with a peak metal roof. A lot of people like those peak roofs to make it look more silo-like. And then in this case, they are covered it with insect netting to keep the mosquitoes and other insects out, because not only do they want to catch the runoff from their greenhouse, but they want to catch the ambient rainfall. This operation happens to be in Florida. And Florida is one of the states that's very, very strict about nursery and greenhouse runoff. And so they want all water collected off the greenhouse and all the runoff from the greenhouse. So it's a very, very elaborate system, a channel, so as they water the plants in the greenhouse, all that water is captured also. Then we also need to think in terms of rainwater capture as a stormwater runoff mitigation. In other words, if we're collecting that rainwater instead of letting it run off of our property, we may be able to get a stormwater credit for that. All of us are charged for stormwater depending on how much impervious surface we have. That's our greenhouse, and that's our parking lot, our potting sheds, our shipping sheds, things like that. Now, if you're out in county and not in a city, you might not have that stormwater charge, I'm going to say yet, because eventually that's going to be charged everywhere, where if you have water running off of your property, you're going to be charged for that because the runoff becomes polluted from fertilizer, pesticides, and soil sediments, erosion. And so someone's got to clean that up. This is a very, very small greenhouse. Well, I don't consider it small. It's about 30 by 50. But again, it's at a nursery, a garden center, and they keep lots and lots of plants in there. They have other greenhouses where they're growing lots of plants. But again, they're collecting that rainwater and using it to irrigate the plants with. Very, very beneficial. So when we think about rainwater harvesting system, it's a system where we're going to store the rainwater so it's available when we need that water, not just when it's raining. And so first of all, we need to filter the rainwater going into our cisterns off our greenhouse. And then we need to look at that water quality that we need in that greenhouse, because you might not think there's anything on the top of your greenhouse, no trees around, no nothing around to be polluted. But I live in Fort Worth, Texas, and I tell you right now, the dust from West Texas that blows into Fort Worth from the prevailing wind from West Texas drops all that dust on my greenhouse. And of course, I have a polycarbonate roof, and it deteriorates that roof faster than normal, but at the same time, it collects on there, and then it collects in my rainwater, so I have to filter that coming out. We also have to consider the distribution, how we're going to put that rainwater into a distribution system, what those emission devices are, and therefore how good do we need to filter that before it goes into the distribution system. We want to filter enough so the particles won't clog up that distribution and emitters. Types of filters could be inline, leaf and insect screens on our gutters, a roof washer, a first flush diverter. All of these are different ways that we can look at it. The water quality requirement, of course, has to do with the crop that we're growing. Some crops are very, very, very sensitive to salt in our irrigation water. And then, of course, if it's a long-term or short-term, crop, we need to consider that with salt buildup in the soil. And then the growing media. What are we using, and how is that going to deal with the salt? Is it easy to leach the salts out? And I'm talking about fertilizer salt as well as irrigation water salt. And then, of course, our irrigation method. And so I have a friend who has this over in Northeast Tarrant County, and she grows topiary geraniums, believe it or not. This is a long, long, long crop. And she is very, very concerned about the water quality. She started out using well water, did not work in any way. Once the water was tested, we almost certainly saw how. It was very, very high in sodium, very, very high in calcium, and so she ended up putting up a rainwater collection system, and that solved her problem. She likes old pots to put these in, and she also likes that patina on it, and her customers like that too, so she's actually inoculating that on the pots for that reason. I'm an orchid grower, and of course this is a long-term investment, and again, my water quality is important, and my pH of my water, the alkalinity of that water, everything is important for this long crop, and particularly for my medium, since it's long term. I don't want to be repotting these things all the time, so of course I need to pick out a potting material that will last a long time. Greenhouse tomatoes, I mean, we all love them. Some of them are irrigated with drip irrigation, some of them are grown hydroponically, but whatever the way they're grown, of course, water quality has a lot to do with it. Leafy vegetables are getting very, very popular to grow in greenhouse. And then microgreens. Microgreens are very popular. You can do this in a very small greenhouse. It's a very, very high cash crop. And so these are going to be cut within 3 to 8 days of planting the seeds, depending on what the microgreen is. Anything from mustard green to bean sprouts are going to be cut. They're going to be put in a hydro washer, and they're going to be put on an airplane within hours after cutting in order to get them to restaurants in the New York area, Washington, D.C. area, San Francisco, and Los Angeles, and of course Dallas. And so the chefs want these microgreens. It's a good, easy to grow crop. Some plants are very sensitive, like carnivorous plants, to the water quality, and we want to grow these. Of course, they capture their own nitrogen if we have any insects in our greenhouse, but sometimes we don't, and therefore we have to add a little bit of fertilizer. Hydroponic growing, whether we're doing it in a warehouse like this, your next door to your office, or wherever you're doing it, again, water quality makes a lot of difference. So greenhouse runoff, where does it go? What does it do? What does it carry with it when it runs off your greenhouse? I talk about dust collecting on the greenhouse. And then in this case, it's a gutter-connected greenhouse, and you can see they have a walkway, or maybe it's a driveway between the greenhouses, and that water is going to go down there, hopefully collect in a lagoon where they can filter the water and put it right back in for greenhouse use. And so this is like the lagoon, and you can see the pump out in the lagoon, and they are collecting all that runoff. Now, what if we didn't allow it to run off? What if we put it in cisterns so that we could filter it and put it right back into our greenhouse operation? So this is what we need to look at. We need to look at that supply. How much water can we collect off the greenhouse? What is the demand? How much water do we need to do our irrigation, counting the difference between our different crops we're going to be using, our different soil media, and then also the different seasons of the year, the age and stage of the plant grow. So our collection system, do we have gutter connected greenhouse with existing downspouts, or do we need to add something to that? Our storage above ground or below ground, and then our delivery method with irrigation. So we can collect about 0.6 gallons of water per square foot of a greenhouse in a 1-inch rain. I have a 33,000 square foot greenhouse. I can collect in a 1-inch rain 1,800 gallons of water. It rains about 32 inches here a year in the Fort Worth area, and so I can collect about 600 gallons of water a year. Now, I'm an orchid grower. I don't need that much water for irrigation, but I also have that humidity system underneath the benches because I have to keep the humidity very, very high. I need really good water to do that. And so you can see I've put up 2 cisterns here. I'm collecting the water off of it. I have a first flush diverter, and I'll talk about that as a filtration system. These are 5,000-gallon cisterns that are at the Fort Worth Conservation Greenhouse at the Fort Worth Botanic Gardens. So what is the demand? What is the water requirement of the crop? Your irrigated area in square feet, your benches or your rows, in the ground, in soil, in pots. What do you need? Of course, the time of year and growth stage of plant. Then, how expensive is this? We need a collection system, we need the cisterns, we need the delivery system, we need an irrigation or submergible pump, maybe a pressure tank, a backflow prevention device if we need backup water. So there's quite a bit of equipment that we're going to need. Okay, now we don't need the dog, but what a cute picture, right? And so the rainwater is coming out of the cistern and through this pump. This is what is called an on-demand pump. It's actually a self-priming pump. Once it's primed, you should not have to prime it again, but you can see I fixed it up so I can prime it again. The water's coming out of here and going into a pressure tank. That takes a water hammer out of the impaler when it's going round and round, you know, to get that water hammer out of there. You can buy pumps that are on-demand pumps with a pressure tank inside the pump or attached to the pump, very, very small pressure tank. That will take the water hammers out. You don't need a big pressure tank like that. Your catchment, of course, your greenhouse roof, the yields, demand, the size, the texture, whether it's poly sheeting, polycarbonate, and whether you have shade cloth on it. Shade cloth does deteriorate over time. It will put some, you know, pollution into your water, but it's easily filtered out with the various filter. Remember the catchment system, the catchment area is the footprint of your greenhouse, not the total square footage if it's a peaked area. The storage, the container, you can use polyethylene, fiberglass, wood, cement, metal, underground, above ground. You want it opaque. You don't want algae growing in there, so the more we can cut off the sunlight, the better. This timber tank up here has a bladder inside there that expands and unexpands as water is put in it. Poly tanks are some of the most affordable, and this is a poly tank that has been painted. The pump is being used by the solar panel. If you know in advance you want to use solar, make sure that you tell the equipment person you're going to go to for the pump that you're going to do that. Underground storage is very, very good because, of course, then we can use the ground, you know, above that, but it's also very expensive. The expense is the excavation, not the containers themselves. But this is a fiberglass container. Of course, fiberglass can be a little bit more expensive. And these are storm chamber containers. That has to be excavated. It has to be tied down into the soil so it's not going to float out of your hole. You have to put the soil back in it after your tie downs are attached. And then you have to look at, you know, how to get it out of there. Usually a submergible pump is used. Pumps push water better than they pull water. So you usually want that pump either in your cistern as close to your cistern as possible. This is another new method of underground. This is a crate system where you actually can excavate a very, very shallow area. This can actually go under a greenhouse or a potting shed or a parking lot if you're in the building plan stage of wanting to do this. And these crates are available that you can have a driveway, a parking lot over them or a greenhouse over them. The water goes in here through a filtration system, and then, of course, it's pumped out with a submergible pump. Metal tanks, a lot of people love the metal look with that peak roof on top. You can also use a flat roof. You can see this has had some solder repair on it, and what we worry about with metal tanks, of course, is metal leaching out of there. You know, aluminum, lead, and iron, particularly if it's been soldered like this. So that has to be checked before we want to use that. A timber tank, like I said, is a bladder method. You can see right here at the base of it, we have the pump, and it's going to pump the water up into, in this case, at the Fort Worth Botanic Garden, a fern garden. On the inside of the tank, we want to look at a couple of devices. When the water comes in, we really want what we call a calming inlet here, because the little bit of debris that's going to get through your filtration system will eventually become a benefit. That sediments will become a biofilter for you in there. And so if we can get the water, instead of splashing down into there, if we have a calming inlet. And then for the outlet, if we have a floating intake with a filter. So here's our filter right here, and here's our float, and that can be a 6-inch ball, and we can put that filter down, 6 inches, 4 inches, whatever we want, off of the surface of the water. So if any petroleum products or any leaves get through our filtration system, those are going to float. And we don't want that collected into our irrigation system. So that's a very, very easy flexible tubing to put on there. And then our overflow. We have to consider the overflow in order to get the extra water out of there. And where is that overflow going to go to? We need to make sure that we've accounted for that's not going to make a mess and create erosion somewhere. So a calming inlet, you can purchase one yourself or make one with PVC pipe. Overflow siphon, the advantage of that, it creates a vacuum, so it's constantly skimming the water off of that surface if it's up there at the intake, which is right here. And then, of course, your floating intake, your flexible tubing with your wonderful filter and your ball and your tether. And so, of course, we also have a hook at the top or an eyelet at the top so that we can tether that to the top of the tank so it never, ever, ever falls down into that sediment area that we don't want it to. Filtering the water going in, there's so many different kinds of filters I could not possibly show you all. They're all going to be different for different ways that we want it. This is at the Tarrant County Community Garden filter. It's just a basket up there. The water goes through it first. The debris collects in that basket. And then we have what is called a first flush diverter, where this fills up with water and it beats all the sediments and dust off of that roof animal and bird droppings down. And I have an elbow there with a plug screwed into it, and I can unscrew that and I can wash all that debris out. Meanwhile, the first flush diverter, or roof washer is the other name for this, fills up with water, and then it comes up and goes into my cistern much, much cleaner than it would if I just let it come straight in from the downspouts. This is a circumfuge one where the water comes in and it goes round and round and round. There's a screen in there. There's a basket in there. That's for a very, very, very large system. This is just an addition to your guttering. This goes into your cistern or your rain barrels. This, of course, does not collect every drop of water, so that has to go into your mathematical calculations when you figure out how much water you can collect off of there. So here's a typical first flush diverter where I'm collecting the water off of this big giant building on our campus. Comes down. I have the first flush diverter where I can unscrew it right here, and then my water fills up, beats all those sediments, bird droppings, everything down here, comes over and into my cistern, where again I can put a filter there. All the inspection ports have a lip on them where you can put a filter basket there. And then, of course, every now and then I need to clean this out. I don't tighten that real tightly so the water slowly leaks out, or I can put a spigot there so that I can clean it out. In this case, Brad is unscrewing that to see what type of debris we've collected. Usually on a very clean roof where there's not a lot of trees involved, that's just going to be sediments in there. So now we're back to our distribution, how we're going to get it back into our greenhouse, what size pipes do we need, what pressure we need in order to distribute the water through the irrigation method we need, whether that's through our garden hose, our drip irrigation system, a boom arm that goes all the way across our greenhouses, what type of pump do we need, solar powered or electric power, and what type of pressure do we need to get our irrigation methods to work properly. Normally, we want about 60 psi going into a greenhouse, and then we can always put a pressure regulator everywhere we're going to use the drip irrigation. Now, if you know for a fact you're only going to use drip irrigation, you could put that pressure regulator, and of course you could use a much smaller pump if you're going to do that. Most of us are going to want to have several different irrigation methods in our greenhouse, so we want that pressure coming out of that pump to be about 60 psi, and then treat the individual drip irrigation methods with a pressure regulator. And so what kind of pump do we need? What type of pressure tank do we need to take that water hammer out of there? Shallow well pump. This is a very popular on-demand pump that has a pressure tank in it, and it also will turn itself off if there's no water in the cistern. And the difference between that and an average irrigation pump is $150, sometimes $200, depending on if you want a half horsepower, a full horsepower, or higher tank pump. But you need to know that that turn off automatically is really, really good. Of course, you could put a flow meter in there and it would do that same thing, but it's another expense and another a device you have to add to your pipe. This is a submergible filter. This is a filtered pump. This is very, very popular, where the water is going to come through this filter and it's going to be pumped up, collected from the, whatever you've set this tether to, 4 inches below the surface, 6 inches below the surface, go through the filter, go through the pump, and then out to where your service area is. A lot of people that are going to put in very, very large systems, this can be tethered in. It's very easy to pull it out through the inspection port, clean it up real well, and put it right back down in there. Any of you that have a well are probably having to do that with your well pump already. Again, pressure tanks are only going to be needed if we're going to have a water hammer available. Oh, wait a minute, I forgot to say one thing about transfer pumps. Believe it or not, I have a real nice, half horsepower transfer pump, and I like it because it has a real nice handle that I can pick it up and move it to clean out my lagoon, to pump water out of my lagoon or my ponds, or also my rainwater collection system. So transfer pumps, believe it or not, if you keep the water filtered, I think I've had this one for 15 years, so they're available to use also. And then we want to talk about filtration. This is a very elaborate filtration system, and this might be what we want to do. And so the size of your filters that you want to filter the water before it goes through your pump and into your irrigation system has a great deal to do, again, with the pressure you're going to need. You can see this pump has a pressure gauge on it, so we can watch that very carefully, because every bit, the length of your PVC pipe, every fitting on your PVC pipe, every valve that you're going to have, if you have separate irrigation systems that are run off of an irrigation controller in your greenhouse like I do, every bench has its own, is sort of its own zone or station. This has a lot to do with the friction loss and the hydraulics, and you have to put that into your mathematical calculations. Then the overflow. We need to allow for an overflow. You want the overflow pipe to be as large as the intake pipe. So if this pipe coming into off my shed is 4 inches or 3 inches, I want the overflow to be 4 inches or 3 inches also. And so then I have to decide where that overflow water is going to go to. Can I put it into a rain garden? Can I put it into a lagoon and use it for other types of irrigation? Then also, we want some sort of device in the overflow pipe so insects cannot fly in there, a mouse cannot crawl up in there and end up in your cistern. So this flapper works really, really good. There are also some insect netting that you could put over it, all kinds of different methods, but the flapper works real well for doing that. Then we have to decide also, if we can't collect the amount of water we need off of our greenhouse, our potting sheds, our office building, whatever method, wherever we have impervious surface and we can collect the water off of, we have to decide if we want backup water. And backup water would either come from your well or your other water source like municipal water supply. In order to do that, then we need to have a backup system where the water's coming in from another supply, and then a float system in order to say how far the water can drop before that backup water starts going into the cistern, and then also set the float so that we cannot allow the whole cistern to fill up with water. I have mine set at 200, so when it gets down to 200 gallons, the backup water will start coming in and allow 200 gallons to fill up the cistern, and no more than that. So that gives me 400 gallons, and of course that can repeat itself many, many times. If you are using municipal water or well water for a backup system, you're probably going to need an air gap. And of course, as 4-inch pipe is coming into there, or 3-inch or 2-inch, that air gap needs to be minimum of 4 inches, but as much as 6 inches if you really want to be safe. And that will keep that water from backflowing into whatever your water source is, whether it's well water or your municipal water supply. Very, very important. And then a water level indicator. That's very helpful for us all to have. Then what are we going to do in a greenhouse situation like this, where we're only doing bedding plans, very, very fast crops, 6 to 8 to 12 weeks, and we're going to take the plastic off during the summer and put shade cloth on? Where are we going to collect our water? Well, in this case, they have a huge, huge shipping and potting and storage operation, and so they've got more cisterns coming off of this really, really large building, and then there's another smaller office building than they do off of the gutter connected greenhouses. So there's always a way to do that. Even off a parking lot you can collect rainwater, believe it or not. Little small potting sheds, large sheds, small greenhouses, no matter what we do, we can do that. The placement, of course, of your cisterns need to be where it's not going to block any light coming into the greenhouse, and of course the north side will be best for that. And then we have to have a firm foundation to put these. Water weighs 8 pounds a gallon. We most certainly do not want the rainwater collection systems tumbling down, smushing that car in your parking lot or rolling down the hill. Again, I want to stress solar power. If we're going to use that, we need to let our pump person know it, and then our irrigation controller if we're going to use that. This is a poly tank that has been covered by wooden slats to make it look a little bit nicer. This is in front of one of our county buildings. You can see the overflow. Well, I should have taken a better picture. It's going to go into a rain garden, and also the overflows from all the gutters are connected into that rain garden too. A rain garden is a rainwater collection system that captures the rainwater, lets it infiltrate very slowly into the soil, and that mitigates the pollution in the rainwater coming off your roof, coming off your parking lot, and then it also infiltrates and hopefully gets down into our aquifers. Cutting tools, of course, I use a hole saw, great deal, skill saw, jigsaw, and then I use drywall saws to make my holes. Mosquitoes are our main worry. We don't want our neighbors, of course, complaining that we're creating a problem with mosquitoes. Other bugs like bacteria, parasites, virus, and protozoa, we don't need to worry so much unless we're going to have that drinking water also. And if that's the case, then we need to put in a proper sterilizing with our filtration, like ozone or UV or chlorine injection. And so we need to consider that. Everything needs to be labeled non-potable. We also put up cisterns for wildlife, and then of course our irrigation method has to be cleaned out every now and then in order to get any debris that's been stopped in there. So what is our maintenance? Our maintenance is mainly keeping our gutters and downspouts clean, cleaning out that first flush diverter now and then keep our filters clean or replace them if we need to. Avoid collecting rainwater during the fall when leaves are falling, or in the spring when our catkins are falling off of our oak trees or off of our pecan trees if we have them nearby. And then if pollen is also a problem, we need to do it there. And so this can be a problem, the maintenance, and so someone's got to maintain this system for you. There are rainwater harvesting professionals that are certified by the American Rainwater Catchment System. Texas A&M actually teaches those classes all over the United States and at the Dallas Research and Extension Center if you're interested in attending those classes. The incentives for it, of course, is getting the salt-free water. Also, in the state of Texas, any supplies you buy for rainwater collection is sales tax exempt, and of course reducing that water bill or your groundwater supply that we need to look at water conservation. And so this is easy, a quick, simple thing to do. We've got a real great resource for you called rainwaterharvesting.tamu.edu. This is the Texas Rainwater Catchment System Association organization. All the professionals in Texas that design and install systems, and also that sells the supplies, if you want to do it yourself, are located there. Of course, we use ET, and of course the measurements here at the Texas ET site are going to be the outdoor measurements, not the inside of our greenhouse. And so I don't know if you measure ET inside your greenhouse, but of course that is one method we can use for irrigating our greenhouses. Agri horticulture, all kinds of resources there for us for greenhouse growing and all the different crops we might want to grow. Irrigation, our Irrigation School of Technology provides many, many classes taught all over the state of Texas that you can take if you want to do the irrigation yourself and maybe even become a licensed irrigator. Dallas, this is the website of the Dallas Research and Extension Center. This is where my office is, and I've got about 17 different rainwater collection system demonstrations there, both the rain gardens, rain barrels, big giant cisterns, and different irrigation methods for that. This is my contact information, and of course getting me by email is much easier than calling me, and I invite you all to ask any questions you have right now, or if you think of those later, please email me with those questions.